We talk about so we start with the sorting algorithm, sorting problem. So, what is the problem of sorting? So, we have given n numbers, say input is n numbers a1, a2, an. So, typically they are integers. We can deal with real numbers also, then we have to deal with real number operation, but these are typically integer. We have given an array of n numbers, then the output will be the permutation of numbers, a permutation of this number ai1, ai2, ain such that it is sorted. So, there are factorial in permutation. So, among this we have to choose one permutation, that one which is giving the sorted array. So, this will be the output of any sorting algorithm. So, this is in ascending order. Okay. So, now for example, if we have say input like this, say if we have input say 6, 3, 2, 9, 7, 10, 11. Suppose this is our input. So, we have 1, 2, 3, 4, 5, 6, 7. We have 7 elements. So, we have an array of 7 elements. So, we have A1, A2, A7. So, then after sorting, output will be the sorted one. So, it is basically a permutation on it. So, 2, 3, 6, 7, 9. So, we should get this to be a permutation which is sorted. So, this is the output of, this should be the output of any sorting algorithm. So, we will talk about, we will discuss some sorting algorithm which will by which we should able to get this output. So, we start with insertion sort. So, we talk about a sorting algorithm which is called insertion sort. So, this is the name of the algorithm. Now, what is the input? Input is n numbers. So, suppose we are taking the number is an array. So, this is the input. So, we have an array of n numbers. So, 1, 2. So, our array is starting from 1 to n, not 0 to n minus 1 like in C language. We are not dealing with any specific language. So, that is why we start our array with 1 to n. So, we have a n numbers and we need to sort these numbers. So, we have to write how we will do that. Okay, that description we have to write. So, that description either we can write in English form, that we do this like this English form, or we will write something in a compact way. So, precise form. So, that form is called pseudocode. So, we will write pseudocode for this. So, what we do? So, we first start with a j loop. J is starting from 2 to n, and then we take the key aj into the key. So, this is the aj value. So, our this loop is starting from 2 to n. So, j is starting from here, okay. And so, this is the second step, and we choose I to be j minus 1. So, I is pointing. So, I is starting with j minus 1. Okay. Now, so what we want? We want, this is the, we want at some point of time j will be pointing here and this is our key. Now we want this part will be sorted. This is the loop invariant, the outer loop invariant. We want this. We want this invariant that throughout our loop this property should satisfy. Wherever j will be pointing, that before that the sub array up to this is sorted. Okay. Now we have to find the, this is the new element, this is now new j. So now if, now this is our I, so I is j minus 1, this is our I. Now if key is greater than ai, then we can just increase j by 1, there is no problem. Then j will be pointing this one and up to this it is sorted, because this is greater than this. So only problem will occur if this key value, if this key is less than this, then we need to find the position of this by shifting this one by one, and each time we must compare with the key value with this values. So that we are going to write, and this will continue until I is equal to 0. If I is equal to 0, we must stop, because there is nothing to compare. So that we will write here. So this is basically while I is greater than 0, this is one condition, and so, and if the key is, greater than ai, we need to do, if key is greater than ai, then we can just increase j and that will be taken care by this loop. But only thing, if k is less than ai, then we have a problem. Okay. Then we have a problem. Then what we do? Then we just do like this. So we shift this by 1. So I will be shifted this. So ai plus 1 will be copied to ai, and I is decreased by I minus 1. So we shift this guy here. So we already stored this value into the key aj. Now we shift this here, and now I is pointing the next one. So now I is pointing the next one. Now we compare this with the, now we compare this with the I, this value with the key. If this value is greater than, then we will put this key here, otherwise we will keep on do like this. So this is the step, and so this will continue like this, 5, 6, and at 7 we just put ai plus 1, we assign this value the key, that is it. So this is the, this is what is called pseudo code for this. So the description we have written is called, this is called pseudo code. This is basically the description what we are doing. So this is not the English description, it is very precise way, we just write what we want to do in this algorithm. So in this, so this is called pseudo code. This is, if you give this code to any programmer can easily run this code in their own computer language like C, C++, Java, anything. Okay. So this is the code. Now as we see, we want to take an example how it is running, and let us just recall again what we are doing. So this is the I, so this is 1, 2 up to n, this is the A array. Now we are starting j with this guy, this is the j, and I is pointing here, I is j minus 1. Because if we start like this, then this is one element, this is already sorted. Now our loop invariant is, so j will be pointing at somewhere, this is the j. Now this is sorted, this is the loop invariant. Now this is our key, now this is our ai, this is I j minus 1, I is j minus 1. Now, if the key is greater than I, then no need to do anything, we can just increase j by 1 by this for loop, that is it. But the problem is if key is less than ai, if key is less than ai, what we do? We shift this 1's position, then we check the key with this. If this is greater, then we put key here, otherwise we keep on shifting this like this until we reach to the end. If we reach to the end, we put the key here, otherwise we will put the key in a suitable position. So, that is the loop invariant where we must look in our algorithm. Okay. So, let us execute this by taking an example. Okay. So, let us take an example. So, suppose we have a given some input, say 6, 9, 7, 2, 3, 11, 10 and 1. Okay. Suppose this is our input, this is the given array and we need to sort this array. This is the given array. There are how many elements? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements, A1, A2, A8. We need to sort it. So, we need to we are going to execute this piece of code, insertion sort. So, what we do? We start with j from 2 to n. So, j is pointing here. So, this is our key and I will be pointing j minus 1, I is pointing here. Now, we compare 9 with 6. Now, 6 is greater, 9 is greater than 9. So, we do not need to do anything. So, we just increase j by 1 and that will be taken care by that for loop, this for loop. Now, again this is our key. Now, we compare this with this. Now, this is again greater than. So, we point this. Now, this is our key. Now, I is this one, sorry, no, I will be the next one. So, I is pointing j minus 1. So, every time I is j minus 1. So, I is pointing here. Sorry, so this will also change. Sorry, so let us just execute from the beginning. So, this is I is pointing here. So, first of all j is pointing here. So, I is pointing here. So, this is greater than. So, j will be now pointing here. If j is pointing here, now this is our I. Okay. Now, we have a problem because this is the key and this is less than this ai. So, if it is less than, what we do? We shift this one position, this is 9 and this is 6. Now, this is our I. Now, we compare this with the key 7, this is greater than. So, we stop this inner loop and we put this key to be ai plus 1. So, key will be put it here like this. So, 3, 1. So, now j is pointing here. Okay. So, this is by the outer for loop. Okay. Now, if j is pointing here, now I will be here. Okay. Now, here again we have a problem. This is the key and this key is less than ai. So, if key is less than ai, what we need to do? We need to shift this and then I is pointing. So, we have to shift this, then 7 this. Now, I is pointing here. So, again we compare this, this is the key. Again we compare key with the new ai. This is again less than. So, again we need to shift this by 1. So, again 7 will come here and I is decreased by 1, I is pointing here. So, again we have to compare this ai with the key. This is key is less than. So, again we need to shift this by 1 and now I is 0. Now, we must stop this if I is 0. So, we stop since I is 0 and we put this key as ai plus 1. I is 0. So, ai plus 1 is 1. So, we put this 2 here. So, now this is our, now j is pointing here. Okay. Now, if we observe this loop invariant. So, wherever j is pointing, before that this part is sorted. This is the loop invariant we want. Before that, this part is sorted, and this is our new element to insert in the sorted array. So, this we have to insert by looking at the position. So, we will shift one by one until we get the position of this new entry, the key. Okay, so this is now our key. So, let us just 2, 6, 7, 9. So, this is our key and this is our I. Now, we compare this key with AI. Now, still key is less than. So, we have to shift 9 here and 7, 6, 2. Now, I is pointing here. Now, again we compare key with AI. Again still it is greater. AI is greater. So, we shift this 7 here and I is pointing here. Now, again 6 is greater. So, 6 will be shifted here. Now, I is pointing here. Now, key is greater than 2. So, we must stop this loop if key is greater than 2, if key is greater than AI, and then we insert. So, I is this. So, we insert the key into AI plus 1. So, I is 1, AI plus 1 is 2. So, we must insert this 3 over here. Now, this is 11, 10, 1. Okay. So far, now this is our J. So, now J is pointing here. Now, this is our I. Now, we compare these two. So, this is our key now. Now, here we are lucky because this key is greater than this AI and this part is already sorted. So, we do not need to do anything. This I will be automatically increased by 1 by this for loop. So, now, so this is no change. So, now this is our I and this is our J. J will be automatically increased by this for loop, sorry. So, this is our J. Now, this is our I now because I is always J minus 1. Okay. So, now I is this. Now, this is our key. Now, we compare this. Now, this is key is less than AI. So, we need to do something. So, we just shift this by 1 and so 9, 7, 6, 3, 2. Okay. So, now I is pointing here. So, if I is pointing here, this is the key. So, we compare this key with this 9 and this key is greater than. So, we put this 10 over here. So, this is 1. Now, J is pointing here. This is the. Now, if you see the wherever J is pointing, so all the element up to that is before that is sorted. Now, the thing is we need to find the position for this guy. This is our now key. Okay. So, this is the key. Now, what we do? Now, this is our I. Now, we compare this, 1 is less than this. So, we have to shift this here and then I will be pointing here. Now, we compare this, again this is less. So, we have to shift this here. So, I is pointing here, again it is this, we have to shift this here like this 7, 6, 3, 2 and now I is pointing 0. So, once I is pointing 0, we stop and we put this one to be here. So, this is the final step of our code, and so this is sorted. This is sorted. So, but you see we will talk about run time of this algorithm, how much time it is taking by this algorithm, that is called running time. How much time it will take to run this code in our computer. So, that is called run time or the time complexity. So, we will talk about that, we will talk about the run time, that is the analysis part of any algorithm. Okay. So, this is the input, this is the output, this is sorted. Okay. So, if we talk about run time, if you see here for this 10, we are just moving one position. For this 11, we are not doing anything, just one comparison. But for this 1, if you see 1 has to come long way to the beginning. Okay. So, one has to compare with everybody. So, one has to come long way to the beginning. So, from there we can think that the runtime will depend on what? So, runtime depend on the input. So, we will talk about runtime, the runtime of our algorithm, runtime of the insertion sort. So, runtime means time taking by time taking to run this code. So, this runtime will depend on what? It depends on few things. First one is size of the input. See, if we have to sort 10 numbers and if we have to sort 10,000 numbers, obviously 10,000 number will take more time than 10 numbers. So, runtime obviously will depend on the input size, that n. So, runtime will depend on n. So, we want to, so runtime is a function of n. So, we want to parameterize the runtime by n. So, you want to fix this n, then we want to talk about the runtime. So, we want to parameter, since it is a function of n, because obviously if number of input is more, then the time to sort will be more. Okay, so we will parameterize this by n. So, that is Tn is the runtime for our code, runtime with when the input size is n, with n input. So, we fix n. Then this is a function, this is denoted by Tn. So, Tn is our runtime of for n input, where n is fixed. So, we fix the size of the input. Now, once we fix the size of the input, then the for our insertion sort, runtime will depend on what? Here if you see this one, for example, if our input is this input, say, now for this 11, we are just not doing anything, just one comparison. But for this one, we have to come long way to the beginning. So, runtime will depend on the input pattern. Okay. So, if the array is sorted, if the input is already sorted, then it will take less time, and if the input is reverse sorted, then it will take more time. Reverse sorted means everybody has to come to the beginning in each step, each for loop. So, it will depend on the input. So, if the input is sorted, then the time will take less, because if the input is sorted, say for example, if our input is say if our input is 4, 6, 7, 9, 10, 12, if this is our input, which is a already sorted array, then if we run the insertion sort, we just compare this with this, stop, this with this, stop, like this. So, this is easier to sort. I mean, this will take less time than if the input is say reverse sorted. Say if we have this input 9, 6, 5, 3, 2, 1, if the input is reverse sorted. If the input is this, then everybody has to come forward, then it is the time will take more. So, this runtime will depend on the input pattern, in the sense that a sorted array, already sorted array, a sorted array is easier to sort, will take less time. A sorted array less time than if the array is reverse sorted, it will take more time than the reverse sorted array. So, runtime will depend on the pattern of the input. Okay. So, if a array is already sorted, then it will take less time. If a array is reverse sorted, it will take more time, because everybody has to come forward in that case. So, based on this, so we will talk about 3 types of analysis: worst case, best case and average case analysis. So, this will depend on, for insertion sort, it will depend on the pattern of the input. Okay. So, we will do the types of analysis. So, first one is worst case. So, worst case means it is taking more time, maximum time Tn is taking. So, we will talk more details in the next class. So, it is taking more time, maximum time it is taking by our code. And the best case, worst case for insertion sort is if the input is reverse sorted, then it is taking maximum time. And the best case is if the input for insertion sort, if the input is already sorted, then we are having the, we are spending the less time to sort it. And there is another case which is called average case. Average case means if we assume the on an average how much time it is taking, but it should be some expectation. So, for expectation maybe we need to take some distribution of the input pattern, and then we talk about the expectation. So, this we will discuss in the next class. Thank you.